This is GATE 2015 set 1 EC question number 27. A vector p is given by p equal to x cube y ax hat minus x square y square ay hat minus x square yz az hat. This is being asked to state whether the p is solenoidal, irrotational. We need to determine that. So coming to the useful data, you need to know if curl of a vector field, say p, implies curl of p equal to 0, it implies that it is irrotational. If divergence of vector field p, which is the dot product, is equal to 0, it says it is solenoidal, that is it has no divergent property. Now knowing this, only thing you need to do with this problem is to find the divergence and curl of this vector field that is given in the question. If divergence comes out to be 0, you tell it is solenoidal. If divergence is not 0, you tell it is not solenoidal. If curl comes out to be 0, you tell it is irrotational. If curl is not 0, it is not irrotational. So first determine the divergence of vector field p, which is given by x cube y ax hat. So I am writing it down: x cube ay ax hat minus x square y square ay hat plus minus x square yz az hat. Similarly, you do curl of x cube y ax hat minus x square y square ay hat minus x square yz az hat. Now this is d dx I cap or ax hat plus d dy ay hat plus d dz of a partial derivative it is. So you just take, this is the operator, you just take the dot product and the cross product with p, so to find out the divergence and curl respectively. So first finding out the divergence, it comes out to be d dx x cube y and it will be a scalar. Divergence is scalar, so this dot product of ax becomes 1 and other terms are 0. Similarly for y, only ay will exist, and this is minus d dz of minus x square yz, and az is 1 and all other terms are 0. So you find this, and this is x square 3x square y minus x square y into 2 minus x square y, it is equal to 0. Since divergence of p equal to 0 implies p vector is solenoidal. Now coming out to find the curl of p, which is a vector and whose direction you just, if this is like the vector field, you just curl your right hand and the thumb points in the direction of the curl. So it is a vector and its magnitude is given by taking the cross product with this operator, and also you get the direction along with it. So now we need to do the derivative and find the cross product. So it is found out like this, or ax hat ay hat az hat, and then you take p's components. We first took the unit vectors and then we took the operators x y z component, and then we take p's, the vector fields x y z component, which is nothing but x cube y minus x square y square and minus x square yz, and we take the determinant. So this will give us the curl. Now we find out this is coming out to be equal to ax hat into minus x square z, because you take the partial derivative with respect to y, and minus, so minus minus becomes plus, and then 0 minus, it opens with plus, it opens with minus, it opens with plus. So when it opens, you take only these terms, so minus ay hat d dx of this, so minus 2x yz, and other term is 0, and this opens with plus az hat, and when az hat opens, you just neglect this row and this column, and in this you do the operation, and this multiplied by this minus this multiplied by this. So when you do that, you are getting d dx of minus x square y square, which is coming out minus 2x y square, and d dy of x cube y, which is minus x cube. So now, as you can clearly see, this will not be 0, so we can say vector field P is solenoidal. From the previous result of the divergence becoming 0, we can write, since divergence of P equal to 0 but is not irrotational, because if it was irrotational, then we cannot rotate, it has no rotational tendency, the curl would have been 0, but the curl is non-zero, so it is not irrotational. So not irrotational, but it is solenoidal. Not irrotational, since curl of P not equal to 0, so it is not irrotational. Not irrotational and solenoidal is the answer. So solenoidal but not irrotational, so answer is A. So A is true, A is the correct option. Thank you.